problem 724, LeetCode. Be sure to watch this video until the end, because there is a high chance that this is the task you will get in your interview. The problem statement tells us that we have an array here, and here it describes what we need to do. Let me show you right away what we need to do. Here. That is, according to the conditions of the problem, we need to make it so that we can go... In our array, for example, if we are at the 7, then the sum to the left and the sum to the right should be equal. So the answer here, judging by the answer we have, is index 3, 0, 1, 2, 3. Let's check it. On the right side, 5 plus 6 gives us 11, and 1 plus 7 plus 3 also gives us 11. That's our answer. So we need to find such a number in our array where the sum on the left is equal to the sum on the right. We need to return the leftmost index, not the value, but the index of our element. If nothing is found, then we should return -1. Another very important point here is that if we are at the edge of our array, there are no elements on the left side, so in this case it will be 0. The same applies to our rightmost element, to the right of which it will always be 0. When I first started solving this problem, I immediately thought that I would just move along some pointer and count all the elements to the left and right using a prefix sum. But actually, there is a much more elegant, much simpler, and much more efficient solution, so be sure to keep watching. And it's precisely with this solution that you can solve this problem and pass the interview. This problem is actually solved using basic math. Look, the first thing we need to do is calculate the sum of all the elements in our array. It equals 28. And then, with some mathematical manipulations, we can find this 6 right here. Let me show you how. When our pointer is on the 1, on the left we have 0, and on the right the sum of all elements is 27. If we move our pointer to the middle, then on the left we get 1. And on the right we get 3 plus 6, that's 9. 9 plus 5 is 14. 14 plus 6, 20. And the specific trick to my efficient solution is not to call this expensive sum function on every single iteration of the loop, but instead to use a much more optimized approach, this kind of formula. So we have the total sum, 28, and we do the following. -1, 27. And after that, when we already have 27 here, we subtract our current element, 7, and we get the same result, 20. So here we have 2 ways to solve this problem. The first way is to simply call this sum, and the second is to use a mathematical calculation to get the same 20, but in doing so, make our solution as efficient as possible. Calling this sum is a very common mistake, and people often make it. But by calling this sum, we make our solution less efficient. And so, see for yourself, that is, now at 7 we can raise it further, then we move ours to 3. Here we get 1 plus 7, here we get 8. And on the right we get 6 plus 5, 11. 11 plus 6, 17. Let's count now. 28 minus 8, we get 20. 20 minus 3, 17. Let's shift it one more time. We take it and shift it completely to 6. Here we get 1 plus 7, 8. 8 plus 3, 11. And here we get 5 plus 6, 11. And we've found our part. That is, this is the answer we need. I found it without using the sum function, but with this kind of mathematical manipulation. Thus, I made my solution simpler and more efficient. Let's take a look at how the algorithm itself works. So first, we actually do the calculation. This 28 here, using sum, that is, we add up all our elements and store it in the variable total sum. Then we need variables to store the result of the sum of the left pointers. At this point it's 0. And then we start a loop using enumerate. In Python, this is a special construct that allows us to access both the index and the value. And we go through our array. Then, inside the loop itself, we have a variable called WriteSum, which shows us the sum on the right side. And here, using that mathematical manipulation I showed you earlier, I subtract from our total sum what we have on the left and also subtract the current element itself. As a result, we're left with the remainder. This is exactly our right value. And then I simply compare. If what we have on the left equals what we have on the right, then we return the index. If not, we simply keep moving our main pointer. And besides that, we add all these elements to our left sum variable. So first, 1 will go here, then 7 will be added to 1, and then 3 will be added to 7. And in this way, if something is found, we return the index. If nothing is found, then our algorithm will never enter this return here. And we will return this -1, just as stated in the problem's requirements. Be sure to subscribe to my channel and check out another video on this problem, where I talk about the 3 most common mistakes and 3 modifications that might be asked when solving this problem. Like the video and write in the comments which other problems you would like to see covered.